All right, this one says solve the system of equations using the most appropriate algebraic method. So because it says algebraic, that means we're not graphing, so you're allowed to use substitution or elimination. It's up to you. It's again, what do you think would be easiest, most efficient, the best way to do the problem? So I look at the first one and I notice like my x's and my y's aren't all lined up. Like I could make them lined up, sure, but I'll say this one's kind of set up to go ahead and substitute. So let's add 2 to the other side. And so I have 2y plus 2. And it was real easy or efficient for me just to go, hey, I found what x equals real quick. Since I did that, I'm going to use the substitution method. Okay, so that's part of what we're looking at today. Like, well, how do I know which one to do? And just what do you want to do? What would be easy for you? Since that was easy for me to solve for x, I'll now take that and plug it in for x, right? So again, like I know the lesson is like, ooh, these are special types, but right now I'm just solving. I plug the x in place of the x, watch your parentheses, finish the rest of the equation here, and I'm just solving for y now. I now have one equation with one variable. Oops, 4 minus 4y. Just trying to get y by itself. Right here, I'm trying to combine my like terms, but I know it's 4 minus 4 is 0. Well, I'm not going to write 0. I'm just going to go, all my y's went away. That's the weird thing that happens. It didn't initially look weird necessarily as I was doing the beginning of the problem, but right there, the second a variable cancels out, I look at what I have left. Even if you had minus that 4 first, okay? I mean, I could keep working the problem. The fact is, what's left at whatever point I realize my variables are gone, I go, hang on, 4 does equal 4, 0 does equal 0. This is all true. Therefore, my final answer is infinite solutions. Okay, so again, don't just write true, make sure like you're recognizing, yes, this is true, but tell me how many points of intersection are there. Letter B. This one, okay, says use the most appropriate method. Nothing looks too crazy yet. Wink, wink. Maybe you already noticed something does. But here, I notice my x's are lined up. My y's are lined up. My numbers are lined up. And a lot of people like eliminating a variable. So if that's ready to go, go for it. And this one in particular is especially nice for elimination because you see there's nothing you have to do to get your x's to cancel. You already notice like, oh my gosh, there's a negative 9x and a positive 9x. I already know those are going to cancel, so let's just get going on this one. Sometimes you'll have to manipulate the equation, maybe multiply one, multiply both to get them to cancel, but here those automatically canceled. So you're like, great, I'm on my way. Then that's when you notice, if you haven't already, that your y's also cancel. Okay, that was not intentional. That was just, wait a second, this is what they're doing to me on this problem. That's okay though. That's what makes this one special. So we were trying to eliminate one of the variables, but it turns out both of them canceled. Well then on this side, I have nothing. Nothing is left. 21 minus 24 is negative 3. Wait a second. No variables. Look at what's left over. Is that true? No. Because that's not true, my answer is no solution. There's no number that you can plug in, no point that you can plug in that will make those two equations work out nicely. It just won't happen, okay? So not true means no solution. True means infinite. Make sure you write the final answer. And keep in mind, most of the time, we're still going to get that one single ordered pair as our solution. That's really the goal. That's what we're looking for. It's just that occasionally some weird stuff starts to happen. Okay? So keep doing what you're doing. You guys are doing great. Go ahead and start the practice.